Decoupler Pulley. My name's Chris Martirano, and I'm one of the business development managers for Gates Australia. And this is the second in a complete series of webinars that will run every second week through to the end of 2020. Our plan is to have some interesting topics presented to you every second week, so stay tuned. There's going to be more information coming shortly. And at the end of this, I'll let you know what our next webinar will be. There's lots of people registered for our call today, including some TAFE colleges. I see some lecturers on there from TAFE colleges and some apprentices as well. There's workshops throughout Australia have also joined, and there are many distributors on our call today as well. So people selling the parts, people installing the parts, and people responsible for bringing you the parts. So I hope you take some of this back to your work environment today. It is an interesting topic, alternators, decoupler pulleys. I dare say it's not a topic that we discuss all that frequently. Sort of one of those components that's set and forget, but we're going to demystify some of that for you today. So sit back, we'll be together for the next sort of 45 minutes or an hour or close to an hour, and we'll get through this. There's a questions section there on your screen, the bottom right hand side of your screen. If you do have some questions, please type them in there. Time permitting, at the end of this session, we'll get to them. I'm hoping to answer all of them adequately, and if I don't, I'll certainly be able to rely on the resources of Gates, not only here in Australia, but globally, to get the right answers for you. So sit back, enjoy, and let's get into it. Priscilla, can you hear me? Did you hear any of that? Sorry about that. I'm having trouble just getting through the pages. Technical difficulties. Just bear with us a moment, please. Okay, again, my apologies for that. Some technical difficulties. PowerPoint's not my strong suit, so thanks for bearing with us. Look, this could be one of the most important webinars that you do attend. And the purpose of this webinar is to demystify the alternator decoupler pulley and why it's considered a sacrificial component. We're going to understand how the alternator decoupler pulley interacts with the rest of the ABDS system. We're going to look at some observations for early detection of failures. We're going to make some recommendations along the way. We're going to show you some best practices. There's a lot unknown about the alternator decoupler pulley, and it's not commonly discussed. So I'm going to attempt to show you with some animations, some videos of the alternator decoupler pulley in operation. There's some things I'd like to show graphically as well. I can't guarantee that all the videos are going to work due to the bandwidth that some people might have out there, but please bear with us. The videos are not very long. There's about 30 to 40 seconds worth of videos throughout the presentation. If you miss it, just hang in there. We'll be back to you as soon as that video completes. I'd like to also say, look, I'm not an expert. However, if there's something that I can't answer, I will rely on the resources of Gates, not only here, but globally, to help me out. No question's a silly one, so I'm hoping that we can get through this and give you a better understanding of this important piece of equipment. Okay. To understand the alternator decoupler pulley, you've got to understand the system that it works within. And the ABDS system, it's what we call it. It's the auxiliary belt drive system. It is complex and it takes some explanation and understanding of the complete system. Understand the possible underlying causes of any problems and any failures. And also note the system is designed in conjunction with the OEMs to be able to transmit the required power to adequately turn the accessories that it's meant to drive. That's why some belts have 4 ribs and some have 14, because it's constructed to be able to transmit the power between components. We're going to also talk about how critical belt tension is in this system and the ability of the belt to wedge properly in the pulleys to transfer power to the accessories. So it's an important part of a vehicle operation, the auxiliary belt drive system. That's what it looks like. That's some of the other components within the system. We obviously are familiar with things like the belts, but there's the overrunning alternator pulley that we're discussing today, idlers, tensioner units, crankshaft dampeners as well. And you find these in all makes and models of all cars in our marketplace. We like to use a phrase called Be System Smart. And that's very, very simply just means look at the complete system in its entirety. Don't focus on a single component. When the technicians out there are repairing a belt or replacing an alternator pulley or something like that, look at the complete system and make sure you inspect it well and give your customer the best possible advice on how that system operates and what's needed to maintain that system or what parts need to be replaced to make sure that that system is operating adequately and efficiently. We use this slide in many of our presentations, and it really just gets us to think about root causes of failures. And we're going to concentrate on some of these, but it's really a starting point because it really drives the point home. There's lots of failures going on around the systems that we're talking about. And sometimes they're not directly related to the manufacturer of the product. But it's indicative of the conditions that we put these parts through. So today we're going to talk and touch base on 3 of these. And the 3 points today are 40% of batteries, our research has shown 40% of batteries just needed charging. And I wonder what that meant for the alternator. Was it an issue with the alternator? Or maybe the decoupler pulley wasn't performing well and was actually freewheeling when it should have been engaged. 70% of alternators, rotating electrical alternators, tested okay at the factory. Was it a fault with the alternator, the reason it was returned? Or was it something else? Was it the belt, for example, not enough tension on the belt? You know, these are all scenarios and examples that happen out there in the field. The last one on there, 99.8% of serpentine belts were forced to fail. Sounds a bit dramatic, but belts put onto systems that did not allow them to reach their targeted life. That's what we're talking about. So there was something within the system that contributed to an early failure of that particular component, which in this case is a drive belt. What we'd like to do is understand what is the root cause of these returns. And I think it's important not only for us as a manufacturer, but for technicians and even parts resellers to really understand the causes behind some of these failures. So we open with these slides just to open your mind a little bit, just to understand and realise that there are other contributing factors to any components within that system. This is a good one. This is a slide we actually use, or that's come out of the US, and it's a pile of belts, and if you look really closely, you'll see a gentleman standing behind it. That pile of belts is well enough chest high, and it represents 2 weeks of returns to one of our distribution centres in the US. The pile of belts that you see on your screen also represents a job that's had to be done twice because the belt's been fitted, For whatever reason, the belt's then come off the vehicle and the belt's been returned to the distribution point. And sometimes what seems like a belt failure is not really a belt failure, but it could be a failure of another component within the system. And on the right-hand side over here, we see stop. And this I thought was quite funny. And it stands for second time, zero profit. So I guess a lot of technicians out there on this call want to do the job once. They want to ensure it's done properly, and they don't want that vehicle coming back a second time. So we want to understand the issue and share our knowledge and research to ensure that we adequately respond to any situations where one of our products is not adequately performing. And it's really important as a manufacturer to know what these are and when these happen, and to get them back to us. Service, when we talk about, and the B System Smart message relates to this as well, and we look at servicing the entire system. And when we talk about a system that isn't operating properly, we want to know about the root cause and the impact that this may have on other accessories within that system. How the alternator may not function correctly if the alternator is replaced and the tensioner is not. You're replacing an alternator, it's not giving you the right readings, or you think there's some issues there. The alternator comes off, it gets returned to the manufacturer, and we see that there is actually no problem with the alternator at all. We really also need to understand the effects of improper tension or even alignments, and getting our recommendation to get the job done the first time. That's very important. And that's very important to a lot of the apprentices out there on the call that are learning this stuff for the first time, that may not have seen or even been involved with the replacement of some of these components. So getting the job done the first time is our aim. I guess it's any technician's aim out there. So this slide is blank, and it's blank for a reason, because I need to get your attention, because there are three extremely important considerations. And we're talking about three important considerations when we're setting up or when we're inspecting a belt drive system. And the first is tension. Any belt drive system within a vehicle has to have tension for it to operate. And the belt tension required is predetermined by the amount of power that we need to transmit. The tension is basically the friction between the V grooves on the belts and the corresponding grooves in the pulley. And it's that friction there that transmits the power to the accessories within that system. So belt tension is determined by power. And it's the requirements of each component that add up to what the OE's engineering to that system. Improper tension will cause premature wear, and inadequate tension could indeed give you belt noise or engine failure codes because the belt is slipping through the tensioner. So tension is one of the three most important considerations to any belt drive system. The next important consideration is damping. Damping is basically smoothing out the peak loads within the system coming through from the belt. The belt's going to be experiencing a lot of vibrations in that system because the accessories are turning on and off. So it's a mechanism where we flatten the peaks and troughs to give it a very, very smooth drive. You'll see this graphically described a bit later in the presentation, but it's important to know damping is a critical attribute. And without proper damping, belt noise, vibration, and accelerated belt wear will happen over time. The next one is alignment. Alignment is critical. Alignment is very, very critical to the longevity of the system. And if you don't have correct alignment, you will get noises. You'll get all sorts of rapid deterioration and failures. The belt must operate on the same plate as the corresponding components. So the pulleys and the belt must be in alignment with each other. You see there, that first one is what we call parallel misalignment. Basically, the two pulleys are on the same plane, but they're out of alignment. So there may have been a spacer or something that was missed when the setup was first put on the vehicle, or during a belt change or a pulley change. Maybe you're missing something. And there are tools that we have to be able to check that belt alignment. There's a very fairly simple laser alignment tools that we display and demonstrate at most trade shows that you have been to that really does pick up misalignment very, very well. The other one there on the right-hand side is what we call angular misalignment. And that's where you've got two pulleys on the same plane, but we've got one pulley that's distorted. And that belt will enter that pulley at an angle and severely wear that belt and severely alter the lifespan of that belt. Remember when we said that 99.8% of belts are forced to fail? Any of these three contributing factors will cause a belt to fail prematurely. If we don't have enough tension on the belt, we've got too much tension on the belt, we have inadequate damping, if our spring and our tension is not performing well, or we've got a misalignment problem, we will cause that belt to fail early, prematurely, 99.8%. So three very, very important aspects and considerations for any belt drive. Now, due to the bandwidth, unfortunately, this isn't playing, but this is a small, oops, let's go on to the end of the presentation. This is an animation here on the right-hand side. There we go. And it's demonstrating what we call belt flutter. So I'm hoping you can see it, but on the right-hand side of this animation, and I'll keep playing it, we see the belt fluttering, and it's fluttering because of a number of different reasons. And the first one there is it's a long span between pulleys. So that belt flutters along because it doesn't have any support between the pulleys. But the tensioner, perhaps it's lost its ability to dampen, and the system has lost the tension within that system. The tensioner has the two basic functions: to provide tension, and secondly, to dampen the peak and trough loads within that system. Another reason why this belt could be fluttering is the belt has elongated. Now, elongated belt isn't new. It's actually quite normal. And over time, belts will wear, and they'll wear and they'll stretch. The tensile cords within the belt are made of polyester, or typically made of polyester. We'll talk about some other unique materials in a second, but if the belt over time is worn beyond its life, you will get some elongation and you will get the belt fluttering. And indeed, some fairly new applications we've seen in our marketplace suffer belt elongation quite early and can cause some catastrophic failures, not only to the components within the drive belt system, but other associated components as well. So that's belt elongation. The other reason that this could be fluttering, it could be the wrong belt for the drive. That perhaps in the auto parts store, they didn't have the correct length and had one that was near enough. Near enough sometimes, unfortunately, is not good enough. Belts are made of very, very specific lengths, and we deviate only by a few millimetres either way to ensure that we have adequate tension on that belt. Because if we don't have, we're going to end up with belt flutter, we're going to end up with lack of tension. We're not driving the components adequately and transmitting that power correctly. So the wrong belt could be an issue. I mentioned before, the majority of tensile cords you'll find in a micro V belt are polyester. But in some applications, tensile cords are made out of an aramid fibre. And what we see there is very, very minimal stretch or zero stretch to be precise. We use that particular cord where we've got a system that is critical, that we cannot have any elongation, and we use these in some very demanding applications so we don't have any belt stretch at all. One thing to please note and keep in mind, If the OE, the manufacturer, has designed in a belt with an aramid fibre tensile cord, it must be replaced with an aramid fibre tensile cord, because replacing it with a polyester cord, you'll get stretch immediately or very soon after installation. It will not last the life of the belt, and we're going back to that 99% of belts are going to fail because of associated components or associated influences. So keep in mind, if it is an aramid fibre cord, please replace it with like for like. Now, I guess, so this is the main part of our presentation. Why an alternator decoupler pulley? You might ask yourself, why? Why is it necessary? Why has there been such a change, and a fairly dramatic change as such? But the answers are pretty simple. You know, the steel pulley's been around for so long. Why is it no longer sufficient? And I guess the answer's right there on my screen. Years ago, a standard sort of 60 amp alternator was pretty standard, and the steel pulley was acceptable. And that alternator was enough to drive all the electrical components on our vehicle and indeed put some power back into the battery and power the system adequately. But over years, as vehicles have progressed and technology has progressed, the advancement and the size of the alternator has certainly changed as well. We've gone from a 60 amp alternator to a 270 amp alternator. And in some of the heavy vehicles and construction vehicles, the alternators are even bigger again. You know, we understand in some bus fleets, they're right up to 600 amp alternators. So they don't talk about alternator decoupler pulleys, they talk about monster decoupler pulleys. So as the vehicles have progressed, technology has advanced, and so has the size of the alternator. And there's a sizable difference in weight and capacity of the two side by side. You can actually physically see it. So imagine getting a 270 amp alternator up and running and at cruising speed. You know, it's going to take some power to do that. And remember, that power is transmitted then by the belt to that alternator. And then what happens when we get into a situation where the alternator has to decelerate, and even more so under rapid deceleration? The weight and the mass of the alternator within that 270 amp system wants to keep spinning. So the inertia wants to keep that alternator spinning and does not want to slow it down in a hurry. So it's critical for the system that we disengage the alternator and allow it to spin freely and take a lot of pressure off the system and other components within that system. So we do that by using the alternator decoupler pulley. This is only one reason the OEMs have gone for this particular system and being able to smooth out this load. Some of the other reasons are having an alternator decoupler pulley actually allows less tension on the belt itself, because it's allowing the alternator to freewheel in certain situations, so that the tension on the belt doesn't need to be as great. And believe it or not, less tension on a belt gives you a couple of % worth of fuel saving, boosts the economy of the vehicle. It also extends the life of the other accessories, the alternator, air conditioning, compressor, and that goes towards all the added durability the vehicle makers are looking for. They want to make sure that their product lasts, that they work through the warranty periods, that their systems are well enough in tune that they don't have problems. And reducing the spinning alternator, a 60 amp alternator, is quite simple, because of the mass just isn't there, and the inertia isn't there in the same way it is with a 270 amp alternator or 270 and above. One thing that's critical, you've got to remember that that alternator pulley is spinning about 3 times quicker than the crank. It's about a 3-to-1 ratio. So if your crankshaft's spinning at about 3,000 or cruising at about 2,000 RPM, that alternator pulley is spinning 3 times quicker. Combined with the weight and the inertia, out of that pulley, out of that unit, it is a considerable amount of mass that's been rotated. So the ability for that alternator pulley to freewheel is critical within that system. So that's the important thing behind the larger alternators, to be able to let the alternator pulley freewheel and disengage from the system to preserve and to protect the other system components within that drive system. Why was this technology so important? Well, all this technology has been driven by consumer demand. And we want to run more accessories in our car. Air conditioning, heating, seat warmers, GPS, advanced lighting, and so on and so on and so on. There's just way too many to mention. So the electrical system within a vehicle has to have kept pace with that increasing consumer demand. There's a lot of things at play here. So going from a 60 amp to 270 amp, that's the reason we've got to disengage that pulley to allow the system to freewheel, to protect components within that system. And the most aggressive amount of freewheel will happen during deceleration, where we decelerate rapidly, where we're coming up to a set of lights or something and we decelerate the system. We want that pulley to disengage. So I hope that's fairly clear. I should have maybe got that graphic to come up a little bit early, but that's the deceleration. We're going from speeding in a vehicle to trying to get that vehicle to stop. And even at a complete stop, that alternator pulley will continue spinning for about 10 to 15 seconds after the vehicle has come to a complete stop. So alternator decoupler pulleys, what do they fit? Well, you'll be surprised. There's millions of vehicles on our road in Australia today that have them in their system. And worldwide, there's about 150 million vehicles on the road that use this particular system. OEMs have certainly embraced this technology, and all major makes globally are using it within all their models and all their engine variants. Even petrol and diesel applications, like I mentioned before, transit buses are certainly using these. And here's a list of some of them. Some of the brand names here you'll be very, very familiar with. You know, some of the Europeans, look, I would say Europeans have had a bit of a head start. It's very European orientated. However, many other makes such as Hyundai and Nissan, Subaru, Toyota are certainly coming up to speed. You see there Mercedes-Benz, we often, view that as the prestigious car make and models within that brand. They will use this particular technology across all platforms and across all engine variants. So keep an eye out for them. They fit many, many millions of vehicles on our road today. So they are definitely an item that you will come into contact with. But what does surprise me is when we're talking to technicians at different trade shows and trade events, and we have them displayed on our stand, it is rarely an item that gets a lot of coverage. We don't talk a lot about it. Maybe there's a bit of misconception on what it does or why, or there's some mystery in how it works. I hope I've been able to clarify some of that and demystify some of that for you. It is essentially a fairly complex piece of equipment, but performing a very essential task. In the Gates range today, there's about 104 part numbers and growing. And if we look again at all those makes and models, you're bound to find one either in your workshop or out in the car park in front of you. Excuse me, just had some of the recent trends with decoupler pulleys, and these are some of the announcements that the main manufacturers have made. And Toyota or Lexus, 95% of new Toyotas, Lexus within North America, I got the slide out of the US, come equipped with an alternator decoupler pulley. And that is in all 4 and 6 cylinder vehicles. Even more so, GM, every new 4, 6 and 8 cylinder engines being designed today will come with an alternator decoupler pulley. Hyundai's got them in all their 4 cylinders. And Honda, it's very, very new to Honda. They haven't embraced it as yet, but their intention is to put them into V6 engines, the Odyssey, Accords, and so on, and will also be in some platforms using the 2.4 litre engines. So in 2013, about 52 million vehicles worldwide. And in 2018, over 158 million are using this technology today. So it is definitely something you'll become more and more familiar with if you haven't already. Different styles. Now, I've spoken about the generic name, the Alternator Decoupler Pulley, but there's actually essentially 2 different types. There's one we call an OAP, which is an overrunning alternator pulley. So simply that allows, during deceleration, that system to disengage for the pulley just to free spin, to freewheel. And it's a clutching mechanism. It only turns in one direction. So it allows the alternator to free spin, not damaging any other components, and it will re-engage when the speed is down to an adequate RPM. It'll re-engage as the vehicle takes off. Quite simple. The next one is what we call an overrunning alternator decoupler. And it's the same basic functions as the overrunning alternator pulley, but it's got a special feature within this. It has a torsional spring combined into the assembly, which adds to the system and adds in the ability to take vibrations out of the system. So it incorporates an additional spring that dampens the vibration or the harshness within that system, and it gives the whole system a much smoother, much more accurate drive. So these are the 2 main types that we see in the market today. And technology will continue to advance, and some of these will become smaller. Some of these will also be able to assist in the driver in the drive system itself by the advancements within the integral part of this system. And basically, their clutching abilities to drive this system. I'm going to okay. These are meant to be 3 animations, but I will explain them to you, and we'll go through them one at a time, and I'll talk through what this particular demonstration setup was. On the right-hand side, we've got a setup that's been set up with a overrunning alternator decoupler. And what we've done is, and there's the alternator there on the top left of that assembly, and that's using the overrunning alternator decoupler. So let's call that the best step. That particular system is ironing out all the vibrations and peaks and troughs within that system. But what we've done to try and replicate, motoring conditions, we spike that system with engaging, disengaging air conditioners and revving the engine and so on. So the animations here would actually show a considerable belt flutter between the tensioner pulley here, which is this component here, and the alternator there. So we actually see this belt fluttering around quite considerably. And it's not what a belt wants to do. Belts do not want to flutter. Fluttering belt leaves the drive momentarily without adequate power. The next one I want to show you is we changed out that pulley, the alternator, overrun alternator decoupler, for a simple solid alternator pulley. And you can actually see there in this still shot, that belt is almost touching the body of the tensioner unit. It has moved so far and it is fluttering so badly that we get huge peaks and troughs in load on that complete system. So it's very, very important that that these components, iron those out. And lastly on this one, we're going to look at the overrunning alternator pulley, and simply you can actually see the blurry picture there is the belt flutter itself within this system. And keep in mind, the lower the RPM, the higher the torsional vibration. So the lower the RPM, the harder some of these components have to work to keep things on track and, you know, reduce the movement that's exhibited. I'll move on to the next slide because hopefully this will work. And this is only a very short slide, but we'll go through it a couple of times and we'll explain as we go. So there we go. We've got a system there that's been injected with all sorts of spikes and troughs in the power. Using a solid pulley there, we see that the amount of belt flutter is considerable, certainly is considerable, as it's trying to smooth out all those peaks and troughs. And the tensioner bearing, or the tensioner pulley there, is doing its best to smooth that out. You can see other areas of the system, the belt is relatively smoother than what we see here between the two pulleys. Now we're using the overrunning alternator pulley, and we see that those peaks and troughs in the load on that belt has been smoothed out. We'll just go back to it a sec. It has been smoothed out considerably. So you see the signs in behind there and the reasons why we need to slow that system down. So again, belt flutter is not good for a system. We're taking the energy out of the system that's at the inappropriate time. And there we go. The overrunning alternator decoupler. So that's the one with the additional torsional spring inside. And we can see there the effects on the belt as it just comes back to its little bit. The overrunning alternator decoupler, you can see there, it's taking up all that torsional vibration. The tensioner is doing its job. The tensioner is protected. The whole system is protected because we're not getting that belt slapping around against the other components and causing additional peaks and troughs within that system. Very, very important for the longevity, for the reliability of that system, that this decoupler pulley is working adequately. We'll just run through that one more time. I think that's really important. Now, I really hope everyone was able to see that. It's graphically very important to see the demonstration and how the changing of the alternator pulley can affect the entire system. Now, we're going to look just very simply at some of the failures and how to diagnose them, and making sure your alternator decoupler pulley is operating adequately, that it's doing everything that it should be doing. So we kind of think of this pulley as a bit of a sacrificial link within the system. And failures can start to show as early as 60 to 100,000 kilometres. So it's really important that when that vehicle is in for a service, that it is inspected, that we do a couple of quick checks to make sure that it is functioning properly. Because this particular component not functioning properly can lead to failures of other components in that system. It will put additional stress on the tensioner, and it will put additional stress on the belt and every other component within that system. So firstly, let's make sure that there is an alternator decoupler pulley fitted, that it's either the OAP, which is the overrunning alternator pulley, or the OAD, which is the overrunning alternator decoupler. And very simply, on the right-hand side there, it should be able to rotate in one direction, but not rotate in the opposite direction. If it rotates in both directions, we have a problem. That means the clutching mechanism within that pulley has been compromised somehow. It's no longer effective. if the pulley rotates in both directions. And lastly, it's incorrect if the pulley doesn't rotate in either direction. There you've got a serious seizure happening, and you've got some real problems with that complete drive system. It's critical to understand what has led to that failure, and we'll explore a little bit about that a little bit further on. But some of the causes or some of the symptoms, the alternator has stopped charging because insufficient RPM. Have a look, is the belt failing? Is the tensioner failing? Is there not enough tension on that system? The next one is the failing decoupler pulley rotates in both directions. Well, you've got a free spin situation in both directions. It must be replaced. You can turn that pulley both ways by hand. The clutching mechanism within that system's been compromised. It's time to change it out. It may have reached its life, and that's just one of the symptoms when it does break down. Or the decoupler pulley is locked in both directions, where we've got some sort of seizure going on, so it's time to replace. Belt squeal. Belt squeal may be experienced if there's excessive tension and motion. Now that might mean because we've got a lack of tension and the belt is slipping through that tensioner without adequate tension, and we've got some belt squeal. Or if there's a buzzing noise going on within the alternator decoupler pulley, have a look at that. That is a sign that the bearings within that pulley assembly have been compromised, and perhaps the seals, or perhaps there's been ingress of contaminants within that system. It will start to buzz. One of the simple ways to identify that is bring the engine up to about 2,000 RPM and then switch it off. And the alternator should run for about 15 seconds beyond that. If there is a buzzing noise within that system when everything else is quiet, then the pulley or the bearing within that pulley is on its way out. It's time to replace the complete pulley. So there's just some of the really simple ways to check the system and diagnose any failures or any pending failures that might be happening in the short to distant future. The next slide here is just on replacement and the disengaging of the pulley. So it's just a replacement of the pulley. There are tools available. Goats certainly have a toolkit that works its way into the splines of that pulley, but just following those simple steps, those 7 simple steps there, will disengage the pulley from the alternator. The specialised tools, the splines on those keys are unique, so you need the right tool to be able to pull the thing off. And to reassemble, just basically do it in the reverse, again using the right tools, some sockets, the splines will engage in your tools and you'll be able to put it on. Very, very important to check the manufacturer's recommendations when we talk about the torque value to do that final nip up. So please be aware and check that manufacturer's recommendations. Look, we're just going to recap a little bit on the different pulleys again within the system. There is a solid pulley. Solid pulley, what we used to have years ago, small alternators driving limited electrical components within the vehicle, small weight, low inertia, low consideration in terms of protecting the other components within that system. Been around for a long time. We'll probably still see them for a little while yet. The next step up is the overrunning alternator pulley, and it reduces the belt vibration. It has that clutching system which will allow the pulley to freewheel under decelerations. What it does also is reduces premature parts wear. So real important advancement in the technology of these pulleys. And the current day, or the more robust solution, is the overrunning alternator decoupler. Exactly the same features and benefits as the overrunning alternator pulley, but has that internal torsional spring that also absorbs vibration. And that's a really, really important characteristic. I'll flip this one blank, and this one, I hope you get a bit of a chuckle out of this. And what we do when things go wrong, or why do things go wrong? Alternator decoupler pulleys are an advancement in technology within our vehicles, and there's sound reasons why they've been implemented. And the reasons are protecting the system, using more robust components like your alternator to drive more accessories, because we as consumers have demanded those accessories be implemented into our vehicles, be integrated into our vehicles, because we want the seat warmers and we want all the electrical stuff that's going on. And I dare say this advancement or this sort of technology will continue. But there is one natural enemy of an alternator decoupler pulley, and it's this guy. It's this guy with the high pressure water cleaning under the engine, or under the bonnet, cleaning out the engine. And look, he probably thinks he's doing a great job, and I'll tell you what, at the end of this, it's going to look $1 million. But the seals within these units are pretty exposed. There is a cap on them, but moisture can get through that cap and work its way into the bearings. If you start hearing a chirp or a bit of a rumble or indeed a hum within that bearing, within that system, it is time to replace it, because contamination within that system causes catastrophic failures, and it will actually seize that system. What happens when that system seizes is very, very simply, your belt turns to spaghetti. We actually received this belt back through our warranty department saying our belt failed and gave us really very limited indication as to why. And we finally determined the cause of failure was a seized alternator decoupler pulley. So it's not only the belts and the inconvenience of the replacement, but it also wears out some other associated components. They end up with holes in all sorts of covers and bits and pieces. So please avoid that. Avoid going in hard with a high pressure water cleaner anywhere near this component. There is a fair bit of science in there, and it's a precision product. It's not an unground or it's not a simple bit of science and bit of technology there. It is a precision product with precision bearings in there. And even though the seals within that system are full contact seals which contacting the inner rings, there will be moisture and ingress that can work its way through. And once we do that, we get the lubricant within that bearing to dissipate, and you get a seizure pretty quickly. Okay, I'm going to wrap up and just do a bit of a summary. And look, we again close off with Be System Smart, and it's looking at the complete system. Looking at the complete system to keep your customer's car on the road, be it a technician, an apprentice, one of the lecturers at the TAFE colleges, but it's really important to look at the system as a whole. Understand that drive belts and components are wear parts. They're not hard parts. They're not going to last forever. So when you get the vehicle into a workshop, take the opportunity to inspect and advise. That's what your customers want you to do. They want you to make the appropriate recommendations based on your experience and their vehicle. And remember, what they're trying to do is keep this vehicle on road and operating efficiently and effectively, and with a degree of longevity, that vehicle is going to be around for a little while yet. So drive belts and components within that ABDS system, so the accessory belt drive system, are not hard parts. They will not last forever. And all parts within that system, we're at about the same rate. Remember, the vehicle's been engineered to certain parameters. So when we work with the OEs and design a belt into a particular application, we work closely with the tensioning mechanisms, the idler pulleys, the other components within that system, and they're all designed to wear at the same rates. So be system smart. Inspect and repair the full system, not just a single part. Consider the idlers, the alternator decoupler or overrun pulleys, the belts, belt tensioners and vibration dampeners, any crankshaft pulleys, anything like that within that system that might need to be inspected, replaced, refreshed, to bring the system back up to to an efficient system. So there's our B System Smart message. Okay, ladies, gentlemen, thank you. Thank you so much for taking part in this webinar today. There are a couple of questions that I'll go through, and I've got one here from David Marston, and he's asked, how can we know what fibre type is the belt? And that was from the earlier slide when I said be absolutely certain when you're replacing a belt that may have an aramid fibre cord with an aramid fibre cord belt, but not replacing it with a polyester belt. And look, for us as belt specialists, there is an easy way. The colour of the tensile cords is very different. In a standard polyester belt, the tensile cords, I believe, are like a light bluish colour, and the aramid cords are a lot duller. They're a lot whiter in colour. However, if you are unsure, always seek the professional advice from either the vehicle manufacturer or indeed the spare parts shop. They will have our catalogues on their system that will bring you to the right belt selection. It's very, very important that you put in the right belt made with the right construction for that vehicle. It is very, very important to do that. And making sure it's the right belt, that it's not a belt that's too long or too short in that operation, because the tensioner only has a certain degree of tensioning ability. If we go beyond that, we may compromise the system. We may compromise the system to the point where we're not getting our belt an adequate belt life. So it's very important. And the next one, how can we print any lecture page or picture, for example, page 19, please? And that was from George Lamanca. George, at the end of this presentation, you'll be sent another email on how you can get this presentation or review this presentation, get the audio and also the presentation in a PDF format. So you will have access to this complete presentation. I think that might even be available as early as tomorrow. So stay tuned, it will be available. Thank you, David. I just got a message here. Thanks for a webinar with great information, for taking the time to answer my question. And thanks again to George as well. Thank you for that. Shane, I really appreciate all those messages coming through. It was at the start a component or a component within a very important system that is poorly understood. And I hope that I've just been able to demystify some of that for you and really get you to understand the importance of this little piece of science that you will find in your engine bays and in many makes and models around the world. It is a very, very important piece of equipment to ensure that the system runs well and to ensure that the system has adequate tension and is performing to its ability to give you the maximum belts and system life. So please reach out if you've got any more questions beyond this webinar. Please stay tuned in 2 weeks' time. So not Tuesday, coming up Tuesday week, which will be a new webinar. And this time we're going to touch on heavy duty. So heavy duty vehicles, so some construction equipment, heavy vehicles will give you a complete overview of all the Gates products that we have that can be applicated to these vehicles. So we'll touch on things like water pumps and drive systems and different hoses that are available, airlines. We'll touch on a broad range of products that Gates can help you with for heavy duty vehicle. Let's call them heavy duty construction type equipment vehicles, off-road, stuff like that. So thanks again for your attention. Thanks for sharing this last hour with us. We've been really privileged to bring this to you. We're pleased that you all joined us today, and we look forward to having you join our next webinars and many of the webinars into the future. And like I said, they're going to run right up until December. There is quite a few in the series, so stay tuned. Thanks again, everyone, and keep safe We'll catch you again. Bye-bye.